are in the uh, vector problem solving session, that vector addition laws that I have taught. On that, this is the second class of problem solving. So this chapter name is vector, and this is problem solving session. I'm just writing it a problem, that is enough to understand. So what I do, this is the number 4 problem. Okay, so the problem says if A is equal to vector A is equal to B plus C, vector B plus vector C, and vector B equal to vector C plus vector A, then the vector C is what? Then the value of vector C, you can say value of vector C. What is the value of vector C? So if I see this equation, these three vectors are related such a way that A is equal to B plus C and B is equal to C plus A. Now if I replace the V vector value here itself, then I can probably turn into a two variable. So vector B is equal to C vector plus A vector plus C vector again. As for this, only V I am putting the value of B here in terms of C and A. Now you see this both sides there is A vector, so whether it is if I bring it on the other side, it will become this, and this will be 2C vectors. So any same vectors in negative one positive, that will result will be 0, whatever be the value of the A vector. So that vector C, the you can say is equal to 0. Now it is vector C, so that means any vector which is 0 denotes, that means vector, this is also a vector, but the magnitude is 0, that means it denotes the null vector. So vector C is proven to be a null vector if these are related such a way that in both terms C is coming, whether it is B minus A minus B, or B minus A, both the results equal to a same vector. So this has to be a null vector which having magnitude is equal to 0, but direction cannot be defined, but it is a vector. It definitely has vector, but it cannot be defined. Okay, so that we have learned in when we are learning the null vector definition. Okay, so moving to the next problem number 5. The greatest and least resultant of two forces. So now force, is a vector, so I need not to write it, but I am writing it on for your understanding, but it is not there in the question paper. So it is treated as a vector. Forces at a point, the greatest at a point are 29 Newton and 5 Newton respectively. Okay. Now then, if each force is increased by, if each force is increased by 3 Newton and applied at right angle and applied at 90 degree right angle, on a particle, the new resultant force is how much? Force is how much? So now the condition is that the greatest and least resultant of two forces at a point are 29 and 50. So this, let's say the two forces vector are F1 and F2. Together it is giving 29 Newton. Okay, and the greatest, so least would be if here, and least would be when one is deducted from other. Probably if I, that can be assumed that F1 greater than F2 if has to be positive result of the subtractant result between the F1 F2, it must be a F1 must be greater than F2. So now this is the two condition. Now this is value, so you can say F1 F2, these are only the values, magnitude, because direction is not there, so we cannot assume any direction. So probably these are the, so if I calculate F1, it is 29 plus 34 or 7 Newton. Magnitude as F2 will be, magnitude will be how much? If I put 17 here, it will be 12. So these are the values of, now both are increased by 3 Newton. So if I say that F1 after increment, if I take it F1 dash, it will be 20 Newton, and F2 dash, both are increased. If I am assuming that the after the increment the forces are dashed, represented by the dash, then this increased by 3, then it will be 15 Newton. So these are the new forces. Now those are acting, now this is 90. Let's say this is F1, this is F2, acting 90 degree. So resultant is how much? Resultant would be how much? This will be the resultant. So resultant, if it is 90 degree, so if this is F1, this is F2, so resultant will be nothing but square root of F1 square plus F2 square. Here you can understand we are taking the mod values of this F2 square. So what is this? 20 square plus 15 square means 400 plus 225. So altogether it is 625, and this will give you 25. So resultant of resultant will be only the new resultant of the force is how much? This is this much Newton. As direction is not needed, so you don't know. Otherwise, if you have to calculate the direction, then I will take this. So the resultant would be this plus this is equal to somewhere this. So this is how much? This is again alpha. Then tan alpha is equal to how much? This here F1. I have taken this one. With F2 it is alpha. The F1 is equal to 20. F2 is equal to 15. So that is equal to 4 by 3. So alpha is equal to tan inverse 4 by 3. Although this is not there in the question, but anyhow it can be easy to find. Okay. This is number 5. Moving to number 6. The resultant of two forces the resultant of two forces in two forces of magnitude 4 Newton and 4 root 2 Newton makes 90 degree with the smaller force, 90 degree with the smaller force. Okay, the angle between the vectors, find the angle between the vectors. Now the smaller force is 4, so I assume it is horizontally, and if it is along the 90 degree, that bigger force will be 4 root 2. Okay, and the resultant of the two forces, let's say this is the resultant, making how much angle with the smaller vector. This is the need of the question. The magnitude is 4 and 4 2 makes 90 degree, 90 degree to each other. This angle is 90 degree set with the smaller force. No, sorry, I made a mistake. The resultant itself making a 90 degree to the smaller force. If say this is the resultant, this is the smaller force 4, this somewhere has to be like this. So then only it is said to be 90 degree. That means alpha is said to be 90 degree. The angle you will make. Okay, now if I assume this is one parallelogram, so now we can follow this rule. So this is your theta, the vectors, this is resultant, the diagonal. So this is 90 degree, alpha is given as 90 degree, so tan alpha is how much? Tan alpha is equal to tan 90. What is tan 90? It's infinite, it's undefined. That means a sin theta by b plus a cos theta is equal to infinite. That means the below term will be something 0. So a cos theta plus b must be equal to 0. Okay, anything divided by 0 is indefinite, means infinity you can say. You cannot get a finite quotient for that. So this has to be the condition where if it is 0, then only this condition implies. So cos theta is equal to minus b by a. Now what is b here? B, this, if I take this formula, there I have taken this is a, this is b. If you are removing the formula, anything with the sign, that will be the this vector, the below vector. So here b is equal to 4 and this is 4 root 2. So ultimately minus 1 by root 2. So minus cos 1 by root 2 is equal to cos 45. So now if it is 45, so definitely it has to be added with 90 plus 45, has to be in the second coordinate. So this is equal to 135. So theta from cos theta is equal to cos 135. So theta is equal to 135. So this theta is equal to 135. So this find the angle between the vectors. The angle between the vector is 135. Understood? Let me explain it again. How I find the resultant is making 90 degree to the smaller one. Smaller one, this I have taken. If you remember the parallelogram formula, there I have taken in parallelogram, this I have taken where this is alpha, this was the theta, this was your a, this I have taken b, isn't it? So there the alpha, the tan alpha, how I find? Tan alpha is nothing but this upon this. This is equal to the vertical. So vertical is how much? This vector, this again, this is theta, means this is also theta. So this is equal to a, this because these are same, the opposite side of a parallelogram. These are magnitudely same and direction will changing. So a sin theta will be the top one and this will be the this plus this. Now this is equal to b plus this is again part A cos theta. So this is the formula. Now if you remember the formula, this tan alpha is can be calculated by this formula. Now again we know alpha is equal to 90, tan alpha is equal to infinity. To this value to be equal to infinity, the denominator has to be 0. Now putting this is equal to 0, what I find, cos theta is equal to minus b by a. Now b is the smaller one, smaller vector. This is magnitude of smaller vector. We divide the bigger vector, 1 by root 2 minus cos 1. You just forget about the minus first. 1 by root 2 is cos 45. So minus cos 45. To convert it to a to change the minus sign, we have to add, because any multiple of any odd multiple of 90 will sorry, no, again I have mistake. Yes, this is the this can also be written as 180 minus 45, because any even multiple of 90 will remain it as cos, because I'm cos, I'm keeping cos. So this is only possible if I take 180 minus 45. Okay, so there I have to, if I want to keep cos here, so it has to be even multiple of 90. So 2 into 90 is 180 minus the angle that will give the, that is in the second coordinate. What, how can I write 45 cos 45? I can write 180 minus 45, the same thing. Okay, because this angle will come to the second second coordinate. Here all sign is positive, here tan is positive. So the 45 can be written as 180 minus 45. There the thing will not change, because 180 minus 45, if I say, if I convert it for 180, cos will be cos 2 into multiple of 90, even multiple of 90, but as because it is in second coordinate, it will be minus. So minus cos 40, so it won't change its value. Or otherwise I can put it like that. This is also possible, because sine of 45 and cos of 45 same. So I can write cos 45 in the form of sine of 90 plus 45. If I say, does it solve the purpose? Because sine will change to cos. No, it will not change the case, because 90 plus 45 will be then the second coordinate. Otherwise sine is positive, but I have to match the minus sign. So this is only possible if I keep the cos 180 minus 45. This is the right one. So your answer would be cos 180 minus 45. That is equal to, again, how much? The same result, cos 135. So now here cos theta is equal to 135, so theta is equal to 135. Okay, so I made a mistake earlier. It has to be, because I have to keep the cos to cos. If I want to change cos to sine, so that would be only multiple, but in that case if I take sine, so that is falling on the second coordinate, but here sine is positive, so it will not match the negative sign. To match the negative sign, I have to keep like that. So that will be that now itself may be very much tough for you, but if I go on the trigonometric ratios thing, that thing can be easily understood. Okay, so this is the answer. Theta will be, the angle between the vectors given is 135. Okay, so now moving to the problem number 7. It is given vector A plus vector B all together. If I take the magnitude, it is equal to individually vector A plus vector B. If it is the case, then find the angle between A vector and B vector. So what is this implies? This implies nothing but A square plus B square plus 2AB cos theta as per the parallelogram law. And what is this implies? This is individually a plus b, isn't it? Magnitude of a can be written as a, and so if I take the square of both sides, it will become a square plus b square plus 2ab cos theta, and if we square it up, it will become a square plus b square plus 2ab only. So now both sides this can be cancelled out. Okay, so now if I take 2ab, so 2ab can also be cancelled out. So this will be 1 here, because cancelling means it is multiplied to something. I cannot write this. This is not a right way of representation. It will fall in trap then. 2ab. So now if I bring 2ab one side and this I am bringing other side, cos theta is equal to 0, you can say. So taking 2ab common, it becomes 1 minus cos theta is equal to 0. So 2ab cannot be 0, because for a product to be 0, either will be 0 or both can be 0. So in any case, a not equal to 0 or b not equal to 0, or neither, their multiplication has to be 0, because these are not null vectors. For null vectors, these are always true, but in any other case, if it is true, because null vector this plus this is equal to 0, this plus this also is 0. But I am not talking about a specific case. I am talking about general case where it is, any other case it is possible. So now this cos theta is equal to 1. So it is possible one is cos 1 is equal to cos 0. So theta is equal to 0 degree. So what does it mean? That A and B are in collinear and they are in a same direction. Then only this will be true. Okay. So this is for now. In the next video, I'll move on to the problem number 8 onwards. Okay. Thank you. 8.